So for the last couple of years, we've gotten used to AI being these amazing thinkers, right? They're writers, they're artists, great conversationalists. But what if they could actually become doers? Well, that's the promise of AI agents, and it's shaping up to be the next huge leap in artificial intelligence. Okay, let's get into it.
I mean, seriously, think about it. The AI on your phone, it can whip up a beautiful sonnet in seconds, but it can't actually reach out into the world and accomplish a real task for you. And that's the fundamental gap that these agents are built to fill, moving from just generating stuff to actually taking action.
So what exactly is it that separates an agent from the chatbots we're all pretty used to by now? We're about to break down what makes these systems so different and, frankly, so much more powerful.
Okay, so according to the AI folks over at Anthropic, the key words you really want to pay attention to here are dynamically direct and maintaining control. See, unlike a simple chatbot that just gives a response, an agent is actually in the driver's seat. It's figuring out its own path to get the job done. And this comparison just nails it, right? A traditional workflow is like a train on a track. It can't deviate. It just follows a fixed, pre-written path. But an agent? It's more like an off-road vehicle. It's constantly analyzing the terrain and making its own decisions in real time, all guided by the AI's own reasoning.
Okay, so this is the cool part. How does a digital brain, like an AI agent, actually do anything? How does it connect to the real world, to things like APIs or databases, or just the internet? Well, the secret is this really fascinating mechanism. And not secret is a capability called function calling, or sometimes you'll hear it called tool use. This is the essential bridge that lets a large language model stop just talking and start interacting. It's how the agent picks up a tool and actually uses it. So this loop is basically the heartbeat of any agent. It goes like this. You ask a question, the model looks at your question and goes, hey, I don't know this off the top of my head, I need a tool. In this case, a weather tool. Your code then runs that tool, gets the real-time data, and then feeds that new info back to the model. Then it gives you that final complete answer. And this whole process, this back and forth, is powered by a pattern called React. It's really simple when you break it down. The agent reasons about what to do next, and then it acts on that reason by using a tool. It sees the result, reasons again, acts again, and just keeps repeating that loop until the whole job is done. Okay, so a single agent is already pretty powerful. But what happens when you give it a whole team? That's where things get really interesting. We're moving from a solo act to a full-blown orchestra. A single agent is awesome for straightforward jobs. But for really complex problems, that's when you bring in a multi-agent system. You can imagine having one agent that's a specialist researcher, another one that's a coder, and a third one that's a code reviewer. They just pass the task between each other, with each one adding its own special skill. Now, to manage these teams, developers use what are called orchestration frameworks. And the choice usually boils down to this one big trade-off: control versus speed. Do you need absolute granular control over every single step? Then you're probably looking at something like LangGraph. But if you just want to quickly stand up a team of agents based on their roles, CrewAI is your go-to for getting things done fast. This all sounds incredible, right? But the idea of agents has been around for a while. So why are they suddenly blowing up right now? Well, the answer, as it so often is, comes down to money. 10 times. Just let that number sink in for a second. 10 times. But 10 times what? It represents a massive reduction in the cost per token. And you can just think of tokens as the basic building blocks for an AI, kind of like words. So when you make each one of those AI thoughts an order of magnitude cheaper, suddenly these complex, multi-step agent processes go from being a cool experiment to being actually affordable.
NVIDIA has this perfect analogy for it. Imagine a high-speed printing press. If you can suddenly make that press 10 times more efficient, the cost to print a single page just collapses. In the AI world, new hardware is that hyper-efficient press. And the tokens? Well, those are the pages.
And you can see that drop in real numbers right here. I mean, look at this. With the same complex AI model, the cost for 1 million tokens drops from 20 cents all the way down to just 5 cents on the new hardware. That's a 4x reduction. That just unlocks all kinds of applications that were way too expensive before.
And this isn't just theory. It's happening right now. In healthcare, Sully AI used this to slash costs by 90%. They're literally giving millions of minutes back to doctors. In customer service, Decagon is making AI voice agents way cheaper and more responsive. And in gaming, Latitude is cutting costs to build these amazing, dynamic, AI-driven stories. So here's the crucial takeaway. The bake deal isn't just that AI agents are getting smarter. It's that they're becoming economically feasible at a massive scale. And that is the real catalyst, the real game changer that's pushing this all forward.
And that brings us to one last really big thought. As these AI agents become our new digital employees, capable of handling complex tasks all on their own and affordably, it forces us to ask a much bigger question. What are the truly monumental problems in science, in business, in society that we're finally going to be equipped to solve?